Hey guys, today we are going to start a new chapter on circles. So there's going to be a lot of words that we might already know, and there's probably going to be some new ones that we might not know, and we're going to go through them all today. Just get a lot of definitions and terminology out of the way. So a circle, we define a circle, and if you want to follow along, I'm in the textbook on page 697. If you want to go along, you can write some of the definitions down. A circle we define as the set of all points that is equidistant from a given point within a plane, so within a two-dimensional plane. And like over here we have a circle. The circle is all the points that are the same distance from the center, which in this case we'll say the center is K. So that's what we define a circle as. How we can notate a circle: right here we have the center of K, so we could either write circle K, or we can use this symbol, draw a little circle, and a K after it. So this we would refer to as circle K. And the center, again, that's going to be the point that each point on the circle is the same distance from. So another really important term with a circle is called the radius. So the radius is going to be the distance from the center to the outside, to any point on the circle. Call this point G over here. And the radius, it's a segment, and it's two endpoints. Well, one of them is the center, one of them is going to be any point on the circle. So we could say the radius of this, the radius is the segment KG. And that's the importance of the radius. Each circle has more than one radii. It could be KG, it can be K if there was another point over here, whatever it's going to. The radius is how far from the center to the circle. Now a chord in a circle, a chord is going to be a segment that has two endpoints that lie on the circle. So let's say this is point L and this is point H, and we have this segment here. H or LH, that segment would be a chord. And it doesn't just have to be that segment, it can go from anywhere else. Like we could have maybe from right down here. We can have segment, we'll call it J. Segment JH, that is also a chord of the circle. Now there is a special chord, and that chord is called the diameter. So the diameter is a chord that has two endpoints on the circle, and it also goes through the center of the circle. So let's say we have point C over here, and it goes through the center over to H. We could say that segment, CH, is the diameter. The diameter of the circle would be CH. Now the diameter has a very special relationship. The diameter is equal to, so diameter is equal to 2 times the radius. Or you could also say the radius is equal to the diameter divided by 2. The diameter and radius are very special. They relate to one another. Diameter is twice the radius. Radius is half of the diameter. And our last term on here is the circumference. So the circumference of a circle is the distance all the way around. So it's measuring how far around, or how far the distance is to go one full lap around the circle. And we have a special formula for circumference. The circumference, or C, is equal to pi times the diameter, or you could say pi times 2 times the radius, also written as 2 pi r. Either one works, and that's how you can find the distance around the circle. You just either need to know the diameter or the radius, and you can calculate the circumference. Alright, so these are the very basics of a circle. We're going to work into maybe something we haven't seen yet. And we're going to talk about different like circle pairs here. So if you're following along in the book, I'm moving on to page 698 right now. So with circles, let's say we have two circles. We'll have circle with radius A, and we'll have a circle over here with radius R. and A will have point B on the outside, R will have point T on the outside, we would say circle A is congruent to circle R if and only if they both have the same radius, or their radii are congruent to one another. So if segment AB is congruent to segment RT, then circle A is going to be congruent to circle R. So whenever we have congruent radii, those circles are going to be congruent to one another. Another really useful fact with circles is all circles are similar to one another. So if you have two circles, they're all going to be similar to one another. And our last kind of pair that we're going to talk about is something called concentric circles. And if we don't know what that is, we have to find out. So concentric circles. These are two circles that have the same center. And now we need to be careful when we name these circles. So let's say we have a circle right here. We'll call it circle C. And then we're going to have a circle that is centered around C, but obviously it has a different radius. So we'll call this point H. That is a point on the smaller circle. And then we'll say down here is point R. That is a point on the larger circle. So since these two circles have the same center, we can't just call it circle C because we don't know which one we're talking about. So we would have to be specific, and we could say we want to talk about the smaller circle. That would be circle C with radius. So we're going to use the radius to differentiate between the two, with radius CH. Or if we want to talk about the larger, circle C with radius CR. Now we know we're talking about the larger. And these two circles are concentric. Okay. So let's talk about just intersections of circles, and we'll do a little problem from the book to see if we're feeling okay. And then we'll be all done for the day. So let's see. If we have two circles, there's really three possibilities that we could have. One possibility, and there's kind of variations of each possibility. There's like different cases. One possibility is we could have two circles. That's a circle, believe it or not. Two circles that don't intersect with one another. Example, two concentric circles. They don't intersect. You also could have two circles that don't intersect that look like this. There's no points of intersection, they're just on their own. So that's kind of the first case, no intersection. Another case you could have is if the circles intersect at one point. So here's a circle, and let's say we have another circle right here, and they intersect at exactly one point. There's one point of intersection. You also could see this like, maybe we have this circle here, and then we're going to have another circle right here within, and they intersect at exactly one point right there. So circle A and circle B have one point of intersection. That could be point C. So those are possibilities. You can have circles that intersect at exactly one point, and then we have the possibility of circles intersecting at 2 points. So let's say we have, ooh, that was a terrible circle. That's a circle. Let's say we have these two circles. Clearly they have 2 points of intersection up here and here. So those two circles can intersect at those 2 points, and you could have different variations of it. You could have two circles like this, and they intersect at these 2 points. There's 2 point of intersections there. So we'll do one problem from the book dealing with intersecting circles and just finding missing lengths. So if you're following along, page 699, we're going to do example 3. And in this example, we are given two circles I'll do my best to draw them. It's not terrible. We have circle R over here, circle S, and then we're given the segment from R to S, and we know these points are C and D. C and D. We are also given, let's see, we are given the diameter of circle S, so D of circle S, let's say D sub S, equals 30. And we are given the diameter of circle R, D sub R is 20. And we know segment DS is 9 units. Our goal is to find CD, and we can also find RC while we're at it. So given the diameter of circle S is 30, we should be able to figure out the radius is going to be 15. Now if you look at the diagram, the radius of circle S is going to be the segment CS. So that would be 15 units. The diameter of circle R is 20, so its radius would be 10. And if you look at the circle here, circle R, its radius would be segment RD. So RD would equal 10. We know DS is 9. Our goal is to find, first off, CD. So we know CS, we know this whole length, and we know DS is 9. So CD, we should see as a subtraction problem here. CS minus DS, that would give us CD. So 15 minus 9 would give us CD. So therefore, CD is going to be equal to 6 units here. And then if we're trying to find RC, this little segment here, we should see that RD minus the CD will give us RC. So RD minus our CD will give us RC. And then we simply have 10 minus our 6 equals our RC. So RC should equal 4. And then we're all done. So we found the 2 missing lengths. Alright, and that's all we have for today. Tomorrow we'll talk more about like the angles inside. We'll start to dig into things we might not have seen with circles. We'll talk about central angles and like the arcs around the angles. Alright guys, have a nice day.